Okay, so we're going to review functions, and these are going to be functions that we learned in Math 1, Math 2, and Math 3. So it's a bunch of different stuff. Our learning target, I can review what I have learned about functions from previous math classes. So this is going to be a lot, but you can pause the video and you can go back and rewatch it as many times as you need. So first thing we want to talk about is a relation. If you don't remember, a relation is a set of ordered pairs. Alright, so ordered pairs are just your xy coordinates. So if I wanted to give you an example, it'd be like 0, 2, then maybe 2, -3, then 4, 4, and then I'll just make up another one, 8, -6. So just xy coordinate points, and you can have a set of them. That's called a relation. So, over your math courses, you talked about 4 different ways that we represent relations. First one is a table. So, if I just had some x and y coordinates, doesn't really matter. So that's what a table looked like. Okay, and then mapping. So if I took that table and I took the x coordinates, alright, and then I wrote down the y coordinates, and we're always going to do this from least to greatest order. And then mapping, I would just draw arrows to which one went with which. So these two go together. 6 and the 2 go together. 7 and the 0 go together. 8 and the -3. So that's how you would map them. Graphing is just graphing your xy coordinates. So I'm not going to graph those. We're just going to do random ones. And then last, you could look at it as an equation. So these are not going to represent these points. I'm just giving you a random equation. So there are 4 different ways to look at them: table, mapping, graph, and equation. So mapping is kind of like what you did in Math 1 in middle school. You don't really use that a lot anymore. Then you kind of went to tables, then you would go to equations and graphs. So usually equations and graphs are what we really focus on. Okay. So you've also talked about domain and range in the past. Domain is the set of x values, and range is the set of y values. Alright, so if we look at this example, we're going to give the domain and range of each relation. So these are 2 different problems. So the first one, my domain is going to be all my x coordinates, and we always choose from least to greatest. So we have a -5, we have a -1, we have a 3, we have a 7. My range is going to be all my y coordinates from least to greatest. So I see -1. The -1 repeats. I don't need to write it twice. Then I have 0, and I have 4. Okay. So, same thing, but we're just looking at a table. And if this really confuses you, you could write out the coordinate points really fast if you wanted to. So, my domain, I have a -3, a -1, I'm out of room, a 1, and a 2. My range, I have a -4, -3, a 0, a 2, and a 5. So just stating the x values and then stating the y values. And then you're usually going to put them in least to greatest order. Okay, so now let's looking at doing this. We're going to do it in set notation, and then we're going to do something called interval notation as well. Okay, so I'm kind of bringing you through Math 1, then Math 2, and then Math 3 is what I'm doing. So if I look at this first one that looks like a weird M, kind of, the x values are going to be how far left and right they go. So think about this. If I keep going on and on forever, it does keep spreading to the left, and it keeps spreading to the right. So the way we would have said that in Math 2 or Math 1, we would have wrote that the domain is all real numbers. and that's just called the Gothic R, or you could have just written all real numbers, same thing. The range is different because it definitely stops going up right here, and it would hit the y-axis at 6. So there's not going to be a y-coordinate that ever gets beyond 6. So the way we would write it is my range is my y values such that y is less than or equal to 6. Okay, if you look at the next one, remember my domain is going to be my x values. There is like a vertical asymptote right here. You would also call that like a discontinuity because it definitely doesn't exist right there. And that point right there, if I were to hit the x-axis, would be at 3. So I'm going to have any point besides 3. So this is how you would have written this in Math 2. My domain are all my x's such that x cannot be 3. So I'm saying anything but 3. If I think about my y coordinates, it hits at y equals 0. So it cannot exist at y equals 0 because there's no point that would go through that graph. So my range is going to be all my y's such that y cannot be 0. And this is called set notation anytime you see it like this. Then in Math 3, we move to something called interval notation. And interval notations are when you use the parentheses and the brackets, and you're reading the graph from left to right if you're talking about domain. And when you're talking about range, you're reading from bottom to top. Okay, so my domain, it definitely is going to go left forever and ever, but it stops right here when x is 0. Okay, so remember domain is talking about x's. My x's don't go beyond 0. So remember I read them from left to right. So I would say my domain is from negative infinity to 0. I always put parentheses around infinities, and I put parentheses around things that it doesn't actually equal, but I put a bracket around 0 because we definitely have a coordinate point at 0. Alright, my range is going to be a little easier because it definitely goes down forever and it goes up forever. So my range is from negative infinity to infinity, and you always put parentheses around the infinities. Okay, look at my next one. Notice that I have an open circle right here. That point is not that. Let's see, negative 4, comma, negative 3. And this point is closed in, but it is at point 1, comma 2. So when I talk about my domains, they only go from negative 4 to 1. I'm going to put a parentheses around negative 4 because it's an open circle, but a bracket around 1 because it's positive. Alright, when I talk about my range, I go all the way down here. That point is at negative 2, negative 7. So my lowest y-coordinate is negative 7. I'm going to put a bracket because it actually exists. My highest y-coordinate is 2. And I'm going to put a bracket because it actually exists right there. So those are a little weird. There are extra resources if you don't understand this. So if you don't remember this from Math 1, Math 2, and Math 3, you're going to have to put in some extra work because you don't remember it. Go watch the extra videos, take the extra notes, do the extra credit. Don't be a victim, figure out what you're going to do to pass this class. Alright, so then after relations, we talked about functions. A function is a special type of relation in which each element of the domain, whoa, that disappeared because I'm writing in the wrong place. Each element of the domain is paired with exactly one element of the range. So we said for every x, there is only one y. So we're going to determine if these two down here are actually functions. So if you look at the first one, when x is -3, it only has a y-coordinate of -4, so exactly 1. When x is -2, it only has a y-coordinate of -2. When x is 2, only has a y-coordinate of 1. When x is 5, only has a y-coordinate of 4. So yes, this would be a function because for every domain, there's only one element in range. If I look at the next one, when x is -7, y is only 2, good. When x is -5, y is 2, good. So that's not good because you have a repeated range value. Alright, also right here, when x is 2, y is 8, but when x is 0, y is also 8. So here's what you need to remember. The range cannot repeat. So this is a no. So anytime a y-coordinate is repeated, no can happen. Okay. And then we talked about stuff like the vertical line test. Okay, so the vertical line test is pretty easy. If a vertical line intercepts a relation at more than one point, then the relation is not a function. So this first one, if I draw a vertical line through any of those points, I'm only going to hit it one time. So yes, this one is a relation. But if I do this one, notice that it hits at 1 and 2 places, so this one is a no. So that's just another way that you could look at if it's a function or not. Okay, so let's look at something called explicit and implicit equations. So an explicit equation is an equation solved for a specific value. So notice this one, y is by itself. So that's an explicit equation. So an implicit would be an equation not solved for a value. So x is not by itself, y is not by itself. That's an implicit equation. So directions. We're going to write each equation explicitly in terms of x. If it's in terms of x, it means solve for y. So then we're going to indicate whether it's a function or not. So I'm trying to get y by itself. The first thing I need to get rid of is that x. It's positive, so I'm going to subtract. So I have -4y equals 20 minus x. And then the last thing I'm going to do, remember I'm trying to get y by itself. Because the -4 and the y are being multiplied, I'm going to divide everything by -4. And I do mean everything when you do this. Okay, so this becomes y equals -5 plus, that's a 1/4 x. And if I wanted to write this properly, I would put the x part first, the number by itself. And then you can check that this is a function, but this is a yes, just to save time. For the next one, remember I'm trying to get y by itself. So I'm going to move that x squared to the other side. Because it's positive, I'm going to subtract. So I have y squared equals 25 minus x squared. If I wanted to write that properly, I would put the x part first. But it really doesn't matter. The last thing I'm going to do, remember I'm trying to get y by itself, I got to get rid of that square. The opposite of squaring is to square root both sides. So when you square root of y squared, it's just y equals, this will be the square root of -x squared plus 25. Always remember, anytime you take a square root, there's an understood plus or minus. This one is actually going to be a circle, and that's not a function. Alright, now let's look at some function notation. Okay, and this is where people get a little confused. So an equation might look like this, 3x minus 5. A function would look like this, f of x equals 3x minus 5. There's no difference. F of x and y are the same thing. You just have to remember that. So this is read as f of x anytime you see that. Alright, so what we're going to do is we're going to evaluate each function for the given value. Evaluate, anytime that you say that, it means to calculate. Your answer should be a number. Notice that when we say f of x, and now I'm trying to find f of negative 5, I have replaced x with negative 5. That's what it's telling you to do. Everywhere there's an x, you're going to write a negative 5. So this is negative 5 squared minus 6, negative 5 plus 23. You're just going to write that, put that in your calculator if you don't want to do mental math. You get 78. Moving on. Notice the x has been replaced with a 9. That's what you should do. Everywhere you see an x, you're going to write 9. Everything else stays exactly the same. I'm going to put that in my calculator. I get negative 74. This is really easy as long as you understand that you're replacing x with a number and you're putting parentheses around that number. They replaced x with 4. Everywhere you see an x, you need to write the number 4. So I replaced x with 4. I put 4 in parentheses because that's just a good habit to get into. This one's a little different because I'm going to do the top only first, so I get 5. And then I do the bottom only, and I get 35. And now when I divide these two, I'm going to get 1/7. So that's a little weird. Anytime there's a fraction, do the top, then do the bottom, then put it together. Alright, last one. We're going to replace x with 2a plus 7. And we're going to put that in parentheses. This answer is not going to be a number because we did not replace x with a number. We replaced it with an expression, so my answer needs to be an expression. This one gets a little tricky because if you don't remember simple stuff from Math 1 and Math 2, then it's going to really be bad. So this means anytime you have a parentheses squared, to draw the parentheses twice. And then you're going to distribute. You're going to FOIL. I hate the word FOIL, but that's what you're doing here. Alright, and then you're going to get this big old thing. Now, this is understood like a -1. Anytime there's a negative in front of a parentheses, you have to distribute. So you're going to get negative 2a minus 7. And then that -1 at the very end. The very last thing that you always do is look for like terms. So my final answer is going to be 4a squared plus 26a plus 41. If you don't understand something about that, then you can message me and I'll try to help you. Alright, then we're going to look at evaluating functions but looking at a graph. So we're not given an equation, we're given a graph. Okay, remember this is just like f of x. So it's basically telling you x is -2, what is y? So if I look on this graph, the only point that's going to have an x of -2 is that point right there. That point is -2, 0. So when x is -2, y is 0. Y equals 0. Boom, moving on. Same thing with this one. Remember, this is usually f of x. So they're telling you that x equals 0, so you're trying to find what does y equal. Look on the graph. The only point that would have an x coordinate of 0 is all the way down here. That point is 0, -8. So when x is 0, y is -8. Alright, that was a lot, I know. We're going to do some more on domain and range in the next lesson. So if you understand everything but domain and range, good. You can do your assignment and move on. If you don't understand something in here, let me know. There's extra resources to check out. So if you are confused right now, rewatch the video. Go look at the extra resources. Message me for help. Message somebody else for help. If you just want to bury your head in the sand because you're an ostrich and you're too afraid to fail, then you're going to fail and get a 0. So quit being a victim. Find something, do it. Let somebody know you need help before the due date. Okay,